I would like to share our experience on this modular retrofitting solution of buildings and to present the first example, the full building retrofitting. Actually, it's not like a full retrofitting, it is only thermal insulation of the external building envelope. So of course, we should take into account ventilation and water supply and heating system. But today, just for this modular retrofitting, we've prefabricated panels. So presentation is based on the result of our European Horizon project, MoConnect, where we were together with the Tallinn University of Technology. So just a few words for the introduction. So of course we all know why we need this insulation, why we need this retrofitting on the buildings. It's of course due to the fact that energy consumption is still very high, up to 250 kilowatt hours per square meters, with some rare maximum cases with 350 kilowatt hours per square meters. And as you can see, where is the pointer? Yeah, it's much higher than we need today, which is 40 kilowatt hours per square meter. And if you take a look on the typical retrofitting packages, which now were already performed in Riga and Latvia before, it allows us to reduce energy consumption by 60%. So, but in average, it could be like a 50–40%. So, but it's not enough. So we need to get this deep retrofitting with a full renovation of whole system, not only this building envelope, but ventilation, heating system, and so on. But the problem is so far we have only less than 5% of all buildings which have been renovated. So in Latvia. Here you can see such a nice map, which was prepared by Ministry of Economy in Latvia. And here is a map with all renovated buildings in Latvia, multi-apartment buildings. So not maybe all the buildings, but the majority of renovated multi-apartment buildings. And as up today, we have 800 buildings, slightly less than 802 buildings renovated. And using this link, we can also check what was done in these buildings and such other technical information. But altogether, we have 38,000, almost 39,000 of these multi-apartment buildings, and we need to renovate them in very, how to say, urgent matter. So we need to increase our retrofitting rate. But we are not alone in Latvia, so we are not behind of Europe. So in Europe is a similar problem. So Europe needs to renovate 250 million homes to the zero energy performance level. So, and anyway, I have started my PhD thesis and finished it already for 10 years ago. And my main justification why I need to do my thesis in 2007 was that buildings are responsible for approximately 40% of energy consumption. But such a number still actual also in today. Now all the articles, all the research studies also begins with such a number that buildings still are responsible for this 40% of energy and for the 36% of CO2 emissions. So of course we have new buildings now, which also increases energy consumption. And 35% of new buildings are over 50 years old, and almost 75% of the building stock is energy inefficient. So, and it's only 1–2–1.5% it was renovated in Europe. So the situation is pretty much similar across Europe. So, but anyway, we need to do something. So what we are doing right now, we are making the simple thermal insulation of the external building envelope. So usually we're using this rendered facades or double facades. Actually, double facades is pretty rare for the retrofitting. Mainly it's rendered facades. And there are a lot of disadvantages. The first disadvantage for me is that we need the extra effort to ensure construction quality, to follow up all these workers which are here on the building site. We need to check how the materials are stored, so to prevent it from the precipitation impact, so not to get it very wet, let's say. Yeah. Also, we need extra time to put a scaffold, extra time to remove it, so extra fasteners for the scaffold. So there are a lot of opportunity for the building owner to follow up this construction quality. Also, as we are working mainly in 2D so far, it's also resulted in the on-site measurements uncertainty. So we're not able to measure it correctly. And as a result, in many cases, there is an accurate estimation of bill of quantities. So, and of course, extra work for the energy auditor is needed to make the energy simulation. If you have all drawings in 2D, usually for the retrofitting of apartment buildings, we are not using 3D and these IFC files and BIM models. It also makes a problem to make this precise energy audit and energy estimation. So there are a lot of disadvantages, and yeah, which can be skipped by alternative technologies like 3D scanning, the use of drones, and all this BIM design. There is it. Yeah, but few words before we start on this modular retrofitting about our multi-apartment buildings. Actually, there are a lot of disadvantages for our multi-apartment buildings, as you know, small flats, not energy efficient houses, and etc., but indoor quality. But also these disadvantages may be an advantage. And for today's presentation, I would like to highlight this homogeneous external wall. Actually, it's a good thing for us if we are here going to implement mass retrofitting. We have a homogeneous external wall, so it means very easy to renovate it. So we have a brickwork or lightweight concrete. So in Europe, in Scandinavia, they already have some small thin layer of thermal insulation on the wall, and it makes this retrofitting slightly harder. Yeah. And also another good thing is the efficient shape of the building, and also the buildings which were built in early 50s and 60s, they are very primitive, let's say. They don't have a balconies, they don't have any extra shapes, extra forms, and so on. It's also very well fits for this mass prefabricated retrofitting. So because there is no need to insulate the balconies or lodges, let's call it, and so on. Of course, the buildings which were built in 80s, late 70s are slightly complicated. They have a balcony, some extra shapes, and not so very rectangular shape, and it's maybe could be harder to use these prefabricated models. But also the share of these 50s, 60s buildings built in 50s and 60s are pretty high to be successful in this direction. For these purposes, for the prefabricated panels, we can already use existing manufacturers. So we have a lot of companies which are working in the field of wooden houses, prefabricated houses, and they can be easily adapt their technologies, their production lines, also for these panels, which can be used for this retrofitting of the buildings. And actually, since all the work takes place in a closed environment, we can ensure perfect quality. We can choose the best materials, we can apply them in a most accurate way, and to follow up the technology and the requirements of producers. Also, we can we can combine different materials, we can choose also different materials and make a very fast decision and to replace materials according to the house owner requirements or customer requirements. How it looks like, for example, here, like just a small draft of this possible panel, we can take it, we can discuss it later on in more details. And here are some examples from Latvia and Netherlands, so Denmark. So we can easily place this panel in a whole facade. It could be vertical or horizontal layout. We can use it for example, there is a 2-story building, 4-story building, so very easy to place it on the facade, but not so easy like it looks like here. And during the manufacture process, this is existing wall, for example, and there is an air gap between this our panel and the existing wall. This air gap can be filled with different ceiling types. You can choose the best material which fits needs of real building. For example, we can just leave air gap if it's not ventilated. We can use different types of ceiling tapes or soft mineral wools beds or soft ceiling tape, for example, just to seal down these joints. And yeah, also we can use different materials as wind protection barriers. Like here, we can use mineral wool, we can use a plasterboard. So actually, as a main thermal insulation layer, we can use also different types of installations. So actually it could be ecothermal installation, which could be blown in, it could be polystyrene or mineral wool, etc. So also this technology could be slightly very easily modified and adapted according to this customer requirements. So in order to place these panels, also we need to be sure that our walls are vertical and to check how smooth our walls are. And we did some small research using this 3D scanners and drone scanners. We check the vertical deviation of typical walls. So we choose this 5-story multi-apartment brick building, 9-story multi-apartment panel building, and 2-story brick building. And here, for example, for this 2-story building, you can see that vertical deviation is pretty, not to say critical, but we can, yeah, it makes our problem, it makes it harder to place the panels. You see the 40 millimeters deviation from the vertical. So there is a 0 line and we have a 40 millimeters. So some slight deviation in the vertical directions of our brick wall, and there is a 30 millimeters. For the 9-story buildings, we have found there is deviations could be up to 27 millimeters in the vertical direction. So it means that our walls are not straight enough, and it's make a problem for us to fasten it. So if a bigger declination of wall is, we need more fasteners to fix our panels on the wall and more durable these fasteners. And for the 5-story brick building, also the deviation also up to 48 millimeters in the vertical direction. So this should be taken into account during the selection of proper fasteners. And the fasteners are pretty expensive and makes the whole technology slightly more expensive, not the more, but slightly expensive than rendered facades, for example. So it's only like 3 buildings were tested during our preliminary study. And then for our retrofitting process, we did this 3D scanning using the drone technology. Then the model was transferred into EFC model by hand. And then using the standard approach like a SOMA software, which accepts these IFC files, extensions. So it was possible just to create this layout of the panel. It was created like automatically without any, so of course with some hand and human involved, but not it wasn't such high as if we were drawing by hand in a 2D dimensions. And then actually the same EFC model was used for this dynamic energy simulation. So in case if we are going to use prefabricated retrofitting approach, so we should use 3D scanning, and this 3D scanning makes the whole process much more easy in terms of design, selection of most optimal panel layout, and for energy simulation as well. And after the 3D scanning was performed, also we have found that unfortunately not only the vertical deviations took place in all our buildings, but also you see also all the windows wasn't placed horizontally perfectly. So it also makes a problem for selection of optimal panel layout in order to prevent overlap of this panel frame and window. So also here was a pretty significant human involvement to make to select these dimensions and to make the precise placement of the windows in order to avoid later problems with the panel mounting. And then after the 3D model was used, we were able to make these dynamic simulations using the, for example, IDI software in our case, and all exported drawings were also exported in the thermal bridge simulation softwares, and we were able to define this thermal bridging. As you can see, in comparison to rendering facades, we have a lot of, not a lot, but we have a bigger share of thermal bridges due to all this wooden frame, wooden frame vertical and horizontal. And there is examples of automated layout of the panel. Yeah, you see the pretty high share of the wooden frame inside this window, inside this wall, in comparison to rendered facades. But anyway, the thermal bridges wasn't very crucial, and actually there is some increase, only up to 5% in comparison to rendered facades. So the extra losses due to thermal bridges are not crucial. If the bigger thermal insulation is, if the better thermal insulation is, the lower impact will be of such a thermal bridges, like here in the corners or in the ceiling or on the top of the building close to the ceiling. So it's also, yeah, not such very crucial. And if we take a look on these costs, for example, the panel cost for building with 4 apartments, total area was up to approximately 210 square meters. And the panel cost were 28,000 just for the panel. And other construction works, just to make this building site ready for the work, was almost 10,000. So this is a biggest share. Also, other construction works includes a crane for the panel mounting. And the whole process took only 5 days on site, and the panel production was 25 days, but it was like a maximum. In reality, they can reduce this production time twice. An architectural project took only 1 month, including the 3D scanning, development of 3D model. So you see that all the process is pretty short in comparison to traditional retrofitting. So, and on site only, once again, it was 5 hours. And the total costs, yeah, for this whole building was 57,000 euro. Here also you can see the different also modifications. And just a few words like to say as a conclusion. So it was possible to deliver all the panels in one truck. So all necessary panels, it required only 1 truck delivery. So the crane was used for a few days. And yeah, we have a supporting structure right here on the basement. And also we have left this electric wire inside. It was also a discussion with the electric company, and finally they allowed us to leave it here on the facade. So providing a small gap for these electric wires. And there is supporting structure. We used the typical fasteners for this, and yeah, this is a panel layout which was insulated by the perimeter with this mineral wool sealing tape, just to avoid air circulation inside this between the main wall and this prefabricated panels. The main, actually, one problem took place in last panel. So during the panel placements, the small inclination took place like a few millimeters, so we were not able to place it correctly in a 0% degree, and the last panel was with some small overlay. So, and also it was extra time to reorder the new last panel. So it also highlights the importance of this correct panel placement. So they're using just regular level to check the vertical deviation, but also for the future work, we need to use these laser levels and to check how the panels are placed in order to avoid this final panel overlap. Extra time was used to prepare the windows. Here, just to cut out this brick below the window, let's say this down the window. It also took a few days to prepare the buildings, but in general, 5 days to place the panels, and then also like a few days to finalize, to finish all these window areas and the window junction, wall window junctions. So yeah, and yeah, thank you for your attention. It was like a quick review of our modular retrofitting.